स्टूडेंट, आज हम डायफ्रैक्शन को समझते हैं। डायफ्रैक्शन इज अ बेंडिंग ऑफ लाइट बाय ऑब्स्टिकल और ऑब्जेक्ट एजेस। द बेंडिंग ऑफ लाइट बाय ऑब्स्टिकल्स एजेस इज कॉल्ड डायफ्रैक्शन। चीजों के किनारों से लाइट का बेंड होना। जैसे ही मेरे पास ऑब्जेक्ट है मार्कर, इसके एजेस, ये एज है, ये एज है, इससे टकराकर लाइट का स्ट्रेट जाने के बजाय बैंड हो जाना, इस अमल का नाम है डायफ्रैक्शन। मेनली देयर आर टू टाइप्स ऑफ डायफ्रैक्शन, फ्रैनहोफर एंड फ्रेस्नेल डायफ्रैक्शन। Fresnel diffraction, the diffraction in which light source and screen. What is screen? Behind surface. Just if I am the object, light is coming from here. This is behind surface, that is called screen. Or at finite distance from object. Finite means limited. The distance which can be measured is called Fresnel diffraction. यानी अगर ऑब्जेक्ट के करीब ही सोर्स हो और करीब ही पीछे बिहाइंड सरफेस स्क्रीन हो, तो ये डायफ्रैक्शन फ्रेस्नेल डायफ्रैक्शन कहलाएगा। जैसा कि ये आप देखें स्क्रीन फिगर में, ये हमारे पास ऑब्जेक्ट है, ये सामने लाइट सोर्स है और ये बिहाइंड सरफेस है स्क्रीन, ये ब्लू में देखें। अब लाइट रे आई, यहां लाइट रे आ रही है, जा रही है, ये ऑब्जेक्ट के एज से टकराई तो यूं डॉटेडली सीधी जानी चाहिए थी, मगर ये बैंड हुई, ये यहां आई, फिर ये बैंड होकर यहां आई। दिस लाइट रे विच हैज टू गो अ स्ट्रेट, सो it will not go to straight but it will bend from here. This is called diffraction. This is diffraction. From this point to this point there is a darkness. No light can enter in this region. So there is a darkness. This darkness is called shadow. In this diffraction we get shadows. इस diffraction में हमें क्या मिलता है? Shadow होता है. Here is a illuminated place. Light, rich light at here, but if there is no light, that is called darkness. The obstacle object has sharp edges. वो object जिसके sharp, तेज edges होंगे. Its shadow will clear border line. उस shadow क्या करेगा? Carry करेगा clear border lines. यानी हम बता सकते हैं कि here is the border of this shadow. The object which have dull, rough edges, its shadow will carry dull edges, dull border lines. Written at here, the object has rough edges, its shadow carries dull edges or border lines. वो ऑब्जेक्ट जो जैसे हमारा हाथ है, इसके एजेस शार्प नहीं है, किस तरह के हैं? ये हैं रफ एजेस, तो जो इसका शैडो होगा वो क्लियर बॉर्डर लाइंस नहीं रखता होगा। अब दूसरी टाइप है फ्रैनहोफर डायफ्रैक्शन। फ्रैनहोफर डायफ्रैक्शन इन विच द लाइट सोर्स एंड स्क्रीन आर इन फाइनाइट डिस्टेंस। फॉर एग्जाम्पल, flying bird at a height or flying aeroplane. If a bird is flying at a too much height, then from the sun the light rays will be on the bird and also diffracted by the bird wings, edges, whatever it else, just like aeroplanes. But there is no near surface, behind surface or screen on which they produce darkness and illuminated surfaces. So there will be a diffraction but having no shadows due to far away behind surface, just like at here. The object will receive parallel light rays and leaves parallel. So this is the object. In air there is no behind surface and no near light source, so light rays are coming parallelly and leaves the object parallel. This is at here, these are the diffractions. This is called Fraunhofer diffraction. There is another diffraction grating. What this diffraction? The diffraction performed by grating element. And what is a grating element? It is a strip type which contains too many, thousands, hundreds, number of slits in form of lines called lines on the grating. So this is a grating element. It is written at here. Grating element is a strip which contains too many slits in form of lines, that is maybe in 1 centimeter 1000 lines, 1500 lines. This is microscopically and this is macroscopically. When the light rays falls on the grating element, then many light rays will bounce back or absorb, and from the gap or from the slits or from the lines, many light rays will pass. Let ray 1, ray 2, ray 3, ray 4, ray 5, ray 6 and so on. These light rays are diffracting from the grating element. So this is called diffraction grating. Let light rays are diffracting from the elements. The ray 1, this is the ray 1, has covered more distance than ray 2. Ray 2 has covered more distance than ray 3. Look at here. The ray 1 has more distance by drawing a perpendicular, just like we have drawn in the Young double slit experiment. So the ray 2 has covered less distance than the ray 1. So we draw the perpendicular from S2 on R1, from S3 on R2, from S4 on R3. So we get the path difference d sine theta. So path difference d sine theta, d is the distance between two slits, theta is the deviation angle. We get brightness by placing a convex lens, then the light rays will gather at here, so we get the brightness. So the brightness will be produced by the constructive interference, the both having the path difference m lambda. By comparing these two path difference, we get d sine theta equals to m lambda. D distance between S1 S2 or S2 S3 S3 or S4, theta deviation angle. So student, m order of the ray or wave, m equals to 0 1 2 3. In किस order की ray है? 1 2 3 whatever it tells. Lambda is the wavelength. Now student, d is the distance between S1 and S2 or S2 S3. This is the d. It is very difficult to measure it, and d is that a plus b. What is a? A is the width of slit. Slit की चौड़ाई, जिस the passage of light ray, and b the ending of S1 to the initial point of S2, that is the difference between S1 and S2. Since d is difficult, so a and b are also too difficult. For easiness, scientists proposed another method for calculation of d, is that length of grating element. The length of grating element, that is the length L divided by number of lines. 1 centimeter or 1.5 or 2 centimeter divided by the containing lines. 1 centimeter divided by 1000, 1500, whatever. We get the d distance between the slits. Student, diffraction remaining topic is X-ray diffraction through crystal. What are X-ray? X-rays are high energy invisible photons having wavelength 10 power minus 10 meter or 0.1 10 power minus 9 meter, that is A naught. So these X-rays only diffracted by those elements which have distance between their atomic planes equals to wavelength of X-rays. एक्सरे इतनी छोटी वेवलेंथ है, विजिबल लाइट के बाद की जो वेवलेंथ है वो एक्सरे है, अल्ट्रावायलेट जिसे हम कह सकते हैं, वो सिर्फ उन एलिमेंट से डाइफ्रैक्ट होगी, बैंड होगी जिनके एटॉमिक प्लेन्स। अब एटॉमिक प्लेन्स क्या हैं? वो हैं क्रिस्टल। एटॉमिक प्लेन जैसे क्रिस्टल क्या है, फाइन अरेंजमेंट ऑफ एटम्स के क्रिस्टल में क्या होता है कि तमाम एटम्स एक दूसरे से इक्वल डिस्टेंस पर होते हैं, फाइन अरेंजमेंट ऑफ एटम्स। जैसे हमारे पास सॉलिड्स की दो फॉर्म है, अमॉर्फस और क्रिस्टल। अमॉर्फस रफ मटेरियल होता है जिसमें टेढ़े मेढ़ी शेप होती है, जबकि क्रिस्टल में क्या होता है, फाइन अरेंजमेंट ऑफ एटम्स होते हैं, इसीलिए हमें क्रिस्टल अच्छा भी लगता है। So crystal are fine arrangement of atoms having equal distance with surrounding atoms. Every atom with its neighboring atom, if a distance is 10 power minus 10 meter, so here is also 10 power minus 10 meter, 10 power minus 10 meter, 10 power minus 10 meter. So the line of one atom row in a crystal is called array. Many arrays, one array, two array, three array, four array, form a crystal lattice. Lattice means जाल. Crystal structure we can say crystal lattice, and many crystal lattice form a crystal. Crystal lattice, crystal layer, one layer, two layer, three layer, this form a total a crystal. So student, X-rays are coming on this. Let we observe 1 and 2 X-rays. R1 is coming and strike on the first atom of this crystal and diffracted in this way. Second is coming, strike on the second, diffract on this way. Third is coming and diffract on this way, and so on. From where the crystal is broken, then X-ray will go straight. When X-rays fall on a crystal and diffracted by atoms of crystal as shown in figure, ray 2 has covered more distance than ray 1. ray 2 ने ray 2 के मुकाबले में ज़्यादा distance cover किया, so part difference, just like young double slit and in the diffraction grating, draw perpendicular from this point on this and this at here. We get here is both rays are parallel covering same distance. This is the more distance covered by ray 2, d sin theta to come in, and also more distance traveled than ray 1 of ray 2 going out, that is d sin theta to go out. So total path difference is d sin theta to come in and d sin theta to go out is 2d sin theta. By the X-rays diffraction through crystal we get brightness, so the path difference of constructive interference m lambda. By comparing these two we get 2d sin theta equals to m lambda. This equation is also called Bragg's law. Bragg scientists have created this situation. So d in this equation, d distance between atomic planes, theta deviation angle, m order of X-ray, lambda is the wavelength, order of X-ray 0, 1, 2, 3 and so on.